So part D of the problem says find the total electric field by evaluating the integrals. So we'll have to do an integral for the x part, an integral for the y part, and then together that'll give us the total electric field. Let's start with the x part. So we have our element for the electric field. We calculated that in part C. Now what we'll do is we'll do an integral to find the total electric field in the x direction. So our total x component of electric field is the integral of dEx. Fill in what we had for dEx. Now with our integrals, we can take the constants out front. K and lambda come out front. X is a variable, so x has to stay inside. Here's a good time to think about the limits. We want to go from some initial x value to some final x value. Let's think about the rod. Okay, this end of the rod we said was at x equals 0. This end of the rod is the length of the rod, x equals L. We want to go from one end of the rod to the other, so let's go from the right end to the left end. So here will be our x initial, here will be our x final. So x initial equals L, x final equals 0. At this point, you can evaluate the integral yourself, or you can look up the result in a book. So when we look up the result in a book, we get k times lambda times minus 1 over square root of x squared plus y squared, and that is evaluated at 0 and L. So to carry on, we do k times lambda outside of. We plug in 0 for our x, so we get minus 1 over square root of 0 squared plus y squared. Then we do minus 1 over. Now we plug in L for our x. We get L squared plus y squared. Okay. This whole part is going to be minus 1 over y, so we can fill that part in next. K times lambda outside of minus 1 over y. Minus times minus gives us a plus. 1 over square root of L squared plus y squared. Now we can just put some numbers in there and we'll be able to solve and get a numerical value for our EX. So K is 8.99 times 10 to the 9. Lambda is our charge density, Q over L. So to put in our Q over L, we have 5.0 times 10 to the minus 6. That's our charge Q, 5 microcoulombs, divided by the length of the rod, which is 10 centimeters or 0.10 meters. Then we multiply by minus 1 over y. Y was our distance from the end of the rod to point P. That was given as 1 centimeter. So 0.01 plus 1 over square root of L squared is the length of the rod, 10 centimeters, 0.10 meters, plus y squared, which is 1 centimeter, 0.01 meters squared. Do all this through the calculator, and we get for an x component of minus 4.05 times 10 to the 7 newtons per coulomb. Take stock of the negative sign. When we drew our electric field, we see that the x component points to the left, so we expect it to be negative. So we're good with the negative sign here because the x component of electric field points to the left. It is negative. So next we'll do the y component.